students, welcome to Sunil's tutorial. I am Sunil Mirwani and today we will be doing this chapter called as gravitation. Let's see this. Let's see Kepler's law. Now, Kepler's law states that all planets revolve round the Sun in an elliptical orbit with the Sun at the focus of the orbit. His first law, there are three laws he has made. His first law is that all planets revolve around the Sun in an elliptical orbit with the Sun at one focus of the orbit. That is Kepler's law. So all planets are going to be moving in elliptical orbit. This law is also called as the law of orbits. So Kepler's law of orbit says that all planets move in an elliptical orbit. Right? Next, he also says that the line from the Sun to any planet sweeps out equal areas in space in equal interval. The line from the Sun to any planet sweeps out equal areas of space in equal intervals. Right? This is called as the law of areas. That means suppose if I had Sun at one place, this is my Sun, and I have an elliptical orbit around it. Right? This is your elliptical orbit around it. Let's consider that from the Sun I draw say 3 or 4 straight lines. Right? Let's consider this is point D, C, B and A. Right? The line from the Sun to any planet sweeps out equal areas of space in equal interval. So if I consider the interval when the Sun moves from A to B, right, and in that same interval if I consider the Sun moves from C to D, in that case that area of ASB will be equal to area of CSD. Fine, do you get this? This is called as the law of areas. Next, the third law that he propounded was the square of the period of revolution. The square of period of revolution of any planet about the Sun is directly proportional to the cube of its mean distance from the Sun. Directly proportional to the cube of its mean distance from the Sun. This is called as Kepler's law of periods. So this is also called as law of periods. This law says that t square is directly proportional to r cube. Right? We've already done this derivation. So we know that the square of the time is directly proportional to the cube of the distance. Next, what do we understand by binding energy? What do we understand by binding energy? Binding energy, the minimum energy required to remove an orbit from a point in the Earth's gravitational field to infinity is called as binding energy. Earth, you have an object here, till here the gravitational field of the earth exists. How much energy should be given so that this object can escape the gravitational field of the earth? The object escapes the gravitational field of the earth, right? The minimum energy that should be given to the object so that it can move from any point on the earth's surface beyond the gravitational field is called as the binding energy. Fine. So let's write this down. Binding energy is the minimum energy required to remove an object from a point in the earth's gravitational field to infinity. That is what is binding energy. Right? Now let's consider that a satellite is revolving in a circular orbit around the earth at a height h from the surface of the earth. Consider a satellite revolving around the earth at a distance of h from the surface of the earth. Right? Let's try to find out if this is the satellite that is moving at this particular distance, then its distance from the center of the earth is going to be r plus h. Right? In that case, then I can say that r is equal to r plus h, where capital R is the radius of the earth. Now, if this satellite is moving, it is going to possess both kinetic energy as well as potential energy. Let us try to find out the potential energy possessed by such a satellite, Pe. Now, the gravitational potential at a distance r from the center of the earth, the gravitational potential at a distance r from center of the earth is given by the formula minus gm upon r. Right? The gravitational potential is given to you as minus gm upon r. Okay. Now in that case, I can say by definition, the work done in bringing a unit mass from infinity to this point in the gravitational field of the earth, this is going to be the work done to bring a unit mass from infinity to a point in the gravitational field. So I can say by definition, the gravitational potential, gravitational potential is the work done in bringing a unit mass from infinity to a point in the gravitational field. Right? In which case I can say therefore this potential is going to be equal to the potential energy of a unit mass. This is the amount of work done. So this potential has to be equal to the potential energy of a unit mass situated at distance r from the center of the earth. Therefore, I can say that potential energy of the satellite is going to be minus GMM upon R. That is going to be the potential energy that is going to be possessed by the satellite. Now, question, why have I put a negative sign? The negative sign shows that work is being done against the force. Okay. Now let's find out the kinetic energy. Kinetic energy, as the satellite moves with a velocity of vc, moves with a velocity of vc, where vc is equal to square root of gm upon r. Therefore, I can say that kinetic energy possessed by the satellite is half mvc square, right? So this is going to be equal to half mvc is square root of gm upon r the whole square. So this is half m gm upon r, right? Square and root gets cancelled. So then this is going to be gmm upon 2r, gmm upon 2r. That will be the kinetic energy possessed by the satellite. In that case, what will be the total energy possessed by the satellite? Total energy possessed by the satellite is the sum of its potential energy and kinetic energy, right? So in that case, I can say that this is potential energy minus gmm upon r plus gmm upon 2r. So I can say gmm upon r, I can take common, in which case minus 1 plus 1 by 2. So this is gmm upon r into minus 1 by 2. So this is minus gmm upon 2r. That will be the total energy possessed by the satellite. Now, once I know the total energy possessed by the satellite, this is the energy that is holding the satellite onto the earth. This is the energy that is binding the satellite to the earth. That means if I give energy equal to this in opposite direction, the satellite will escape the gravitation field of the earth, right? The negative sign shows that it is being attracted towards the earth. So that means if I supply it with an energy, if I supply it with an energy in a direction opposite to this of equal magnitude, the satellite will be able to escape the gravitational field of the earth. So I can say binding energy is negative total energy. So that is going to be nothing but gmm upon 2r. So the binding energy possessed by the satellite is gmm upon 2r. But r is equal to r plus h. Therefore binding energy is gmm upon twice r plus h. That is the binding energy possessed by a satellite revolving at a height h above the earth's surface. Suppose if the satellite is at rest on earth's surface, if satellite is at rest on earth surface, if the satellite is at rest on earth's surface, then the potential energy possessed by the satellite will be minus gmm upon r. The kinetic energy possessed by the satellite will be equal to 0 because it's not moving, therefore its kinetic energy will be 0. Hence the total energy possessed by the satellite satellite is sum of potential energy plus kinetic energy. So that is minus gmm upon r plus 0. That's minus gmm upon r. That will be the total energy possessed by the satellite. Once I know this, I can say that binding energy is negative of total energy. So that's gmm upon r. That will be the binding energy possessed by the satellite. Fine, do we get this thing clear? Next, I had already explained this to you. Let's do this concept once again. What is escape velocity. What is escape velocity? Escape velocity is the minimum velocity with which a body should be projected so that it escapes from the gravitational field of the earth. Right? Now, let's consider a body as being projected with escape velocity. Right? Consider a body projected with escape velocity VE. Right? Now, in that case, the kinetic energy of projection should be equal to the binding energy. Kinetic energy of projection should be equal to the binding energy. Kinetic energy of projection will be nothing but half mve square. Binding energy we just found out is nothing but gmm upon 2r plus h, or binding energy on the surface of the earth is nothing but gmm upon r. Right? So in that case, I can therefore say that VE is nothing but twice gmm upon r. M and M gets cancelled, so twice gm upon r under root. Right? So that is going to be my escape velocity. But on surface of earth, g is equal to gm upon r square. Therefore, I can say that gm is equal to gr square. Hence, the escape velocity will be twice gr square upon r. R and square gets cancelled, so escape velocity is also given by the formula 2gr. Fine, do we get this thing here? So, do we understand what is escape velocity? Right, we'll stop this here for the day. Thank you very much.